Node.js and Express offer developers ultimate flexibility. You can structure your server, handle routing, and manage databases exactly as you see fit. But in an enterprise environment, that lack of constraints becomes a liability. Without a defined architecture, sprawling feature sets quickly degrade into tangled, difficult-to-maintain code. When HTTP routing, business logic, and database queries are tightly coupled within the same functions, it becomes impossible to isolate individual components. You cannot test your logic without accidentally triggering a live database query. Nestjs solves this by removing that flexibility. It imposes a strict, opinionated architecture, heavily inspired by Angular, forcing developers to organize code into highly predictable, distinct layers. Building an application that can scale to millions of users relies on enforcing these strict boundaries from the very first line of code. That organization starts with modules. These act as strict boundaries, encapsulating specific business domains, like users or orders, into self-contained units. Inside these modules, you have controllers. Their only job is to receive inbound HTTP requests, parse the data, and return a response. Controllers immediately hand the actual work off to providers. These are the services and repositories that execute complex business logic and interact with the database. If a controller needs a service to do its job, a developer might be tempted to instantiate it directly by calling new user service. That creates a hard dependency. The controller and the service are now permanently fused together. Nestjs prevents this using dependency injection. A class simply declares what it needs in its constructor. At runtime, the inversion of control container resolves and wires those dependencies automatically. By adding the @injectable decorator, you tell the framework this class can be injected. Because the framework controls how these pieces connect, you can easily swap out components. This modularity lets you manipulate the system predictably during testing. Securing a production application requires a rigid, predictable pipeline for every inbound request. This diagram maps the Nestjs request lifecycle. An inbound request passes sequentially through 4 checkpoints: middleware for basic body parsing, guards for enterprise authentication, interceptors to mutate data, and pipes to validate the payload against strict type definitions. If we zoom in on the guard layer, we see how Nest integrates with tools like Passport.js. By applying a JWT auth guard to a route using the @useGuards decorator, we mandate authentication. Behind the scenes, a configured JWT strategy intercepts the incoming bearer token and mathematically verifies its signature against the server's private key. Once the token is verified, Passport decodes the payload, constructs a verified user object, and attaches it directly to the request. All of this cryptographic verification and object assignment executes entirely outside of your application's core logic. The controller hasn't even been invoked yet. Handling authorization at the framework's guard layer ensures that unauthorized or malformed data is rejected before it ever reaches your business logic. Once the application logic is secure, it must be verified. Continuous deployment relies on automated tests that evaluate the entire system without modifying live production databases. Nestjs facilitates this through the @nestjs/testing package, specifically utilizing the test.createTesting module utility. The testing module perfectly mirrors the production IOC container on the left. However, the .override provider method allows you to target a specific dependency, like a live database, and replace it entirely with a mock repository returning static test data. You are intercepting the dependency injection process. The controller still requests a repository, and the framework provides one, without a single line of business logic needing to be rewritten. With the dependencies mocked, you call create nest application to initialize a complete sandboxed runtime environment in memory. Using a library like Supertest, you can fire simulated HTTP requests at this sandboxed application, evaluating how the routing, guards, and mocked services behave sequentially. This capacity to surgically swap dependencies while leaving the broader architecture intact is precisely what makes rigorous, automated end-to-end testing possible. Passing tests on a local machine proves the logic is sound, but the application still needs to be packaged for deployment. Because Nestjs compiles to standard Node.js, it operates seamlessly within Docker. You can containerize the application and its dependencies into a single, consistent image. This graphic illustrates an automated deployment workflow using a CI/CD pipeline on a platform like GitHub Actions. The process triggers automatically the moment a developer merges new code into the main branch. The pipeline spins up a temporary server, runs the entire supertest end-to-end suite, and if the tests pass, builds the production Docker image. Finally, the pipeline pushes that image to a registry, connects to the target AWS server via SSH, and commands it to pull and run the latest build. By automating this workflow, the pipeline acts as an absolute gatekeeper. It enforces the rule that no human can manually bypass the test suite to push failing code to production. The target for that deployment is typically a dedicated server, like an AWS EC2 instance, hosting the running Docker container. Exposing a Node.js process directly to the open internet leaves the application highly vulnerable to volumetric attacks and port scanning. To secure the perimeter, we place a reverse proxy, like Nginx, in front of the application. As this animation shows, inbound internet traffic hits the Nginx shield first, rather than the internal application. Nginx is optimized to handle external connections. It terminates the HTTPS traffic, managing the SSL certificates to ensure data is encrypted in transit. After decrypting the request, Nginx securely forwards the traffic to the Nestjs container, which is safely bound only to the server's internal local host network. Nestjs functions as a complete production pipeline. By enforcing rigid architectural standards from the first day of development, the framework separates business logic from infrastructure, enabling the automated testing and secure cloud deployments required for enterprise scale.
Enhance your coding skills with us. Don't forget to subscribe to Code 5 Food for the latest updates and tutorials.